Design and analysis of manual seed sowing machine. Project presentation. Batch number 27. Our project guide. Dr. P. Vijayasarathy, ME, PhD. And our project co-guide. Mr. A. J. Voliopa, M.Tech. Presented by Sudha Kar. S. 113017114086. Saran Raj. S. 113017114077. Pravin. P. 113017114066.
Outline of the presentation.
1. Abstract. 2. Introduction. 3. Objectives. 4. Scope of the project. 5. Significance of the study. 6. Literature survey. 7. Observation from the literature survey. 8. Problem identification. 9. Problem overcomes. 10. Parts of machine. 11. Materials used. 12. Status of the project. 13. Experimental setup. 14. Design of seed sowing machine. 15. Fabricated model. 16. Working methodology and steps. 17. Analysis report. 18. Conclusion. 19. Future scope. 20. Reference.
Abstract.
This project is about a seed sowing system with a fitted plow that can be conveniently adjusted with the aid of a bolt and nut. The plow can reach a depth of around 5/8 cm with the attachment. When the plow becomes corroded, it can be quickly replaced. The seed sower that has been attached sows seeds using a sowing disc that is installed in the seed chamber and rotated by a spinning wheel. A sand leveler has been installed in the system to cover the sowed area after each sow. The time it takes to sow seeds has been found to be greatly reduced using this process, saving labor costs and manpower. Keywords: plow, seed disc, seed chamber, sand leveler.
Introduction.
Agriculture is the foundation of India's economy. Cropping is an important and time-consuming task for all growers, and since it is so time-consuming on a large scale, it necessitates the hiring of additional staff. As a result, agriculture machines were created to minimize human effort. The farmer would have to devote more time to planting. However, they have a limited period of time. As a result, more manpower is needed to finish the job in the allotted time, which is more expensive. During manual planting, there is even more waste. As a result, there is a need to create a machine that will assist farmers in reducing their efforts while sowing seeds. The seed disc sows the seeds at the proper seeding rate and depth, ensuring that the seeds are covered by soil. This planter is very simple to use, hence, unskilled farmer is also able to handle this machine. We simplified the design, also made it cheaper and affordable to every rural farmer.
Objectives.
1. The main goal is to increase the depth of plowing into the soil, and the advantage is the machine can replace the plow with a new one when it corrodes. 2. This machine can also plow, furrow opener, sow seeds, level and close the sand, furrow closer, in a single stretch. 3. And this machine can sow any type of seeds.
Scope of the project.
1. To begin this project, the information were gathered through various data collection methods such as inspecting and looking from farmland with farmers, such as the scale and dimension of typical plowshares and other instruments. 2. Then, using SolidWorks software, the parts go through 3D modeling of assemblies and simulations. 3. Each component has undergone geometric and stress analysis.
Significance of the study.
1. The key significance of this thesis is to increase the productivity of plowing land in an appropriate manner, as well as to sow seeds at an equivalent distance and finally to close the seeds with the aid of furrow closers, leveler. 2. All three processes are built on a single machine. 3. This improves tillers' ability to harvest a significant amount of crop in a single year. 4. This prevents the inflation of demand and supply in our world, which means that our country will live on food alone, which is one of the reasons for the country's long-term prosperity.
Literature survey.
Number 1. Title: Design and Development of Seed Sowing Machine along with Fertilizer Sprayer. Name of the authors: Professor P. S. Garan, Patil Nikhil, Patil Chubam, Pawar Ganesh, Rout Madar. Published in the year 2017. Observation. They designed and built a seed sowing machine and a fertilizer sprayer. Filling the seed and fertilizer manually, then manually moving the system to give motion to the wheel. The fertilizer sprayer is powered by a battery. The drive moves the seed sowing mechanism, then the seed hopper and shaft, and the digging process is completed. Number 2. Title: Fabrication and Automation of Seed Sowing Machine Using IoT. Name of the authors: Senthilnathan.n. Shivangi Gupta, Keshal Pura, Shirya Verma. Published in the year 2018. Observation. They created and automated a seed sowing machine using IoT. The seed sowing system has been planned and built, and the seed sowing process has been automated using IoT to reduce human effort. To achieve wireless communication between the computer and also the controller, a change in the microprocessor selection is made. Number 3. Title: Automatic Seed Sowing Robot. Name of the authors: Vidya Yadav, Poonam Bhosale, Jyoti Shinda, Professor Jagdish Haller. Published in the year 2016. Observation. They developed the automatic seed sowing robot. Seeds fall from this seed drum during each full rotation of the spinning wheel, and the seed plantation operation proceeds smoothly and without seed waste. The sowing disc rotates inside the seed chamber, and the seeds fall into the seed chamber through the seed storage tank. The seed buckets gather the seeds from the chamber and sow them in the field at the appropriate depth using a plow. Even if an object comes in front of the seed sowing system, the IR sensor detects it and sounds the buzzer. Number 4. Title: Solar-powered seed planter controlled by using Bluetooth. Name of the authors: Bharat Yadav, Dr. K. M. Kinshi Reddy. Published in the year 2018. Observation. They developed a Bluetooth-controlled solar-powered seed planter. By using this groundbreaking project of seed sowing machines, more time is saved during the sowing process, as well as a significant reduction in labor costs. It is extremely useful for small-scale farmers. Number 5. Title: Design and Development of Manually Operated Multi-Seed Sowing Machine Using Scotch Yoke Mechanism. Name of the authors: Krutik Rana, Salahuddin Sheikh, Briz Shah, Ankit Panchal, Mr. Satish Kumar Verma. Published in the year 2018. Observation. They designed and developed a manually operated multi-seed sowing machine using a Scotch yoke mechanism. This seed sowing machine makes use of a Scotch yoke mechanism to place seed in the farm. The seeds may be put at a constant distance using the Scotch yoke mechanism. The machine is made up of a hopper, a corresponding disc, a bracket, a bearing, a chain sprocket, a shaft, a Scotch yoke mechanism, and spokes. A hopper is provided at the top of the machine that contains seeds. Number 6. Title: Automated Seed Sowing Machine Using ATmega 2560. Name of the authors: B. Annapurna, B. Anusha, SVS Prasad, B. Samanadu. Published in the year 2017. Observation. This seed farm instrument has a high potential for increasing plantation fertility. As a result, the concept can be assembled using staple sources, reducing the commodity volume and making it easily available in open markets. Only IR sensors and a metering system are needed. Finally, they conclude that this machine is malleable, and that it can do the same operation for different seeds. Number 7. Title: Design and Fabrication of Manual Seed Sowing Machine with Fertilizer. Name of the authors: Professor M. W. Anger, Rajiv Indani, Nikesh Jadhav, Vaibhav Kaud, Rahul Kamankar. Published in the year 2015. Observation. They designed and built a manual seed sowing machine with fertilizer. To minimize the cost of the unit, a popular seed storage location is added in this machine. This unit can also be constructed from raw materials, which reduces the overall cost of the project. The only expense is the cost of the metering system. As a result of using this unit, it can achieve distance stability and monitor depth variance for different seeds. Number 8. Title: Design and Manufacturing of Seed Sowing Machine. Name of the authors: Nagesh, B. Adaling, P. Goon, B. Lavate Rahul, R. Main. Published in the year 2017. Observation. Spraying and seed sowing equipment is being designed and manufactured in an effort to conduct these operations more successfully and cost-effectively. To keep the design simple and economical, a locally fabricated unit was used. This project improves protection, decreases human activity, increases performance, reduces workload, reduces worker exhaustion, and lowers maintenance costs. Number 9. Title: Design and Fabrication of Vacuum Seed Sowing Machine. Name of the authors: Deshmukh Prajakta, Pardeshius Mehta, Kad Gayatri, Suryawanshi Manjita, Kale Sachin. Published in the year 2015. Observation: They designed and built a vacuum seed sowing machine. With this unit, we can accomplish neat seed picking and placement in the appropriate. As a result, the area used by the automatic seed sowing system is very little, allowing the machine to function efficiently. Pelacing of seeds specifically also aids in proper plant development. By changing the nozzle inlet diameter of the vacuum seed sowing system, a variety of seeds can be conveniently mounted. Number 10. Title: Semi-Automatic Seed Sowing Robot. Name of the authors: Mosiam, K. Sangol, Deepak, P. Patil, Khatan, A. Demain, Rohit, K. Jatar, Rushiksh, S. Kardal. Published in the year 2014. Observation: They developed the semi-automatic seed sowing robot. Our proposed seed plantation machine has a high potential for increasing planting productivity. It lessens the need for manual labor. More work completed in less time. Quite cost-effective and beneficial. In the future, we will be able to monitor using Zigbee, IR, IoT, and other technologies.
Observations from the literature survey.
It has been studied based on the above literature review that they have used by manual sowing methods. Some are used motors for driving the wheels. It can be controlled by a Bluetooth device. It can be automated by using microcontroller, IoT, AT-Mega3, and, etc.
Problem identification.
Here the significant flaws or gaps in existing knowledge are: 1. The depth of the soil for sowing the seeds cannot be altered. 2. The distance between each seed will not be evenly sown. 3. The cost will be higher. 4. Different seeds cannot be sown in a single seed sowing machine.
Problem overcomes.
The seed sowing machine was designed and built to perform 3 processes in the same machine. This will allow farmers to finish their work much quicker. 1. The depth of the soil for sowing seeds can be adjusted using this machine. 2. The distance between 2 seeds would be equally sown. 3. Farmers will be able to afford it and the cost will be lower. 4. A single seed sowing machine will sow a variety of seeds.
Experimental setup. Parts of machine. Plow. Design of plow is shown in that image.
1. A plow or plow is a farm tool for loosening of turning the soil before sowing seed or planting. 2. The plow region is made up of alloy 5052. 3. Plows were traditionally drawn by oxen and horses, but in modern farms are drawn by tractors. 4. A plow may have a wooden, iron or steel frame, with a blade attached to cut and loosen the soil. 5. Here the plow that can be adjustable and replaceable when it gets corroded.
Furrow closer. Design of furrow closer is shown in that image.
1. It is made up mild steel. 2. After the seed fall, the furrow closer is used to slightly and gently close the seeds with soil without disturbing their position.
Seed bucket. Design of seed bucket is shown in that image.
1. It is made up mild steel. 2. Seed bucket that stores seeds, and with the help of seed disc the seeds will be distributed in a particular distance.
Materials used. Materials used images are shown.
1. Mild steel, low carbon steel, mild steel box section. Mild steel flat bar, rod. 2. Alloy 5052. 3. Furniture roller ball caster wheel. 4. Bolt, on the 2 wheels. 5. Chain sprocket.
Status of project.
1. Several research papers were examined. 2. Farmers' problems were discovered. 3. A seed sowing machine design was completed. 4. A plow that can be adjusted and replaced when it corrodes has been designed. 5. Materials have been chosen and purchased. 6. The seed sowing machine has been fabricated. 7. The plow was analyzed using the ANSYS software.
Experimental setup. Parts and design configuration are shown.
1. Frame. 2. Plumber slot. 3. Rod. 4. Wheel. 5. Ball. 6. Support plate. 7. Chain and sprocket. 8. Socket head cap screw. 9. Top vessel. 10. Middle wheel. 11. Connecting rod. 12. Funnel. 13. Metric spur gear 2M25T20 Pa 8FW, S25020H14L6N. 14. Plate. 15. Hook, plow. 16. Socket head cap screw.
Design of seed sowing machine.
1. Seed sowing machine. 2. Design of seed sowing machine. 3. Design of plow.
Fabricated model.
Front view. Top view. Back view of the fabricated machine.
Working methodology and steps.
Step 1. Went to the farmers and found the problems faced by them. Step 2. Chosen a problem. Step 3. Visit to agriculture firms. Step 4. Analyze the problem and their solutions. Step 5. Selection of materials. Step 6. Found which mechanism is suitable and lowest cost. Step 7. Prepared all components we require in proper dimension. Step 8. Design of machine and their parts. Step 9. Start fabrication. Step 10. Testing of machine. Step 11. Analysis of design using ANSYS software.
Analysis report.
Some analysis reports are shown in the image. 1. Equivalent elastic strain. 2. Total deformation. 3. Equivalent, von Mises, stress. 4. Strain energy. 5. Safety factor.
Cost analysis of the project.
Cost analysis of the project are given in a tabular column.
Conclusion.
1. In comparison to the traditional method of seeding, the above project outcomes guarantee a much more effective, less time-intensive, and worker-friendly machine. 2. It guarantees that you can complete the most work with the least amount of effort. 3. This seed plantation machine has a high potential for growing planting productivity. Until recently, the tractor was the most common traction unit for agricultural nourishment. 4. This seed planting machine's function has been fulfilled by its adaptation. As a result, there is a need to adopt this technology to make it accessible to small-scale farmers. 5. This unit can also be constructed from raw materials, which reduces the overall expense of the project and allows it to be conveniently assembled in readily available factories. 6. As a result, farmers can comfortably afford it. So, we believe that this machine is beneficial to the world and would like to present it to a stable world.
Future scope.
1. For large field sowing, a multi-hopper, seed disc, plow, furrow closer may be attached side by side. 2. A seed sowing system could include a water dripping device.
Reference.
The referred journal article and research papers which we have gone through are given in these slides.
Thank you for watching this presentation.